Let's take a look at this example. We want to find the equation of the parabola, and we're given a vertex of 0, 0 and a focus of 3, 0. One of the best things to do here is go ahead and plot the information that you do have, because that's going to help you gather the components that you need to find the equation that you're looking for. So I started to sketch the information that we had. We have a vertex that's at the origin, and our focus is at the point 3, 0. I went ahead and plotted those two pieces. Now remember, your focus is going to appear on the inside portion of your parabola, inside the curved portion of it. So just plotting those 2 points, we already know that our parabola is going to be opening up to the right. So here I'm summarizing some of our information. We have our vertex and our focus. We know our parabola is going to be opening to the right, and because of that, we know we're going to be using the formula y squared equals 4ax. Now, if we go back and take a look at our sketch, we can also figure out the distance from the vertex to the focus. It's going to be a total of 3 units, so we have our a value as 3. I'm going to go ahead and plug in our value of 3 for a, and this is going to give me y squared equals 12x. Now that's one of the pieces we were looking for because we wanted to find the equation for our parabola. We still need to go back and finish graphing it. Now remember, this a value we had as 3 units. When we go back to the graph, if we count 3 units in the opposite direction, then we can start to find our equation for our directrix. I counted 3 units in the opposite direction. So at an x value of -3, I can go ahead and draw a straight line through x equals -3, and that's going to be the directrix for our image. Now, in order to graph our parabola, we still need to get a couple more points to make sure that our parabola is pretty accurate. We know it's going to be opening up to the right-hand side over here, so you have a couple options. Obviously, you could pick any x value you want if it's greater than 0, because you know your parabola is going to be opening this way. My suggestion to you would be to go ahead and use the coordinates of your focus as a guide in this part of the problem. Let me go ahead and set up our equation real quick, and then we can start to take a look at how to find a couple more points on our parabola. Now I wrote down our equation y squared equals 12x, and I wrote down the coordinates of our focus, which was the point 3, 0. If you take a look at this equation, we're going to end up using the x value off of our focus. When we do that and plug it into this right-hand side of the equation, what's going to happen is we're going to end up with a perfect square on that right-hand side, and it's going to be very easy for us to take the square root of both sides. We're going to end up with some nice whole numbers, which should give us some nice points to plot. Take a look at what happens. We're going to use this x value of 3, and when we plug it into this equation, 12 times 3 is going to give us 36. We can go ahead and take the square root of both sides. And we're going to end up with y values of positive and -6. So let's take a look at what these points are going to be. I'm going to call them P1 and P2. So my x value in this case was a positive 3, and the y values I'm working with are both positive and -6. So my 2 points, P1 I'm going to use as the point 3, -6, and P2 is going to be the point 3, 6. Now we can go plot those on our graph so we can get a more accurate picture of our parabola. I've plotted our points, and now let's go ahead and connect our dots to draw the parabola. Remember that your parabola is going to be connecting this vertex through P1 and P2. The other piece that we can talk about with our parabola is this distance. The distance that connects P1 to P2, it's going right above and directly below our focus, is known as the latus rectum. I went ahead and drew it with a dashed line. If we measure the length of that segment, it's going to be equal to 4 times A. So 4 times, in our case, our A value was 3. So 4 times 3 is 12. So this should be a length of 12 units for that latus rectum.